Okay, now that we speak about securing both the management plane and the control plane, we're gonna get next up to the more complex topic, to securing the data plane. So we're gonna speak about translating traffic to devices and how can we control at the basic level for the CCNA blueprint. How can I control traffic transiting through a router, or we're gonna see basically a firewall back and forward. So we're gonna introduce the concept of the firewall. And you're going to see how many types of firewalls we have, traditionally speaking, from history till nowadays, and which ones we are going to be using still. Like, are going to still be using the old firewalls. The old firewall implementations are going to be using only the new ones. Which ones and exactly why? We're going to see in a couple. So firewall is a system that stands for just basic. Usually, when you don't know what something means exactly. Like if you don't know what a firewall is, or if you don't know what you're going to see, like for example what OCSP is, as long as you know what the acronym stands for, like we're going to see that OCSP stands for Online Certificate Services Protocol, then just by knowing the name and the technology that is going to be related, it's going to tell you exactly what it does. So firewall is a system that stands for wall, so it's composed of two words, wall and fire. So wall means that the system controls like what traffic is allowed to pass the wall and in which direction, like a regular wall. Think about back in the wartime when there were walls of filtering. So few people were allowed to cross the wall from left to right, from right to left. The same thing in here. And fire, which means allow traffic will be heavily inspected to ensure compliance with security policy. So like in war zone, when somebody was passing to a checkpoint, which was a firewall basically, then they were heavily inspected for identity and to make sure that they were being asked what are going to the other direction, what is the scope, what are you trying to do. So the same thing in here. Now, generically speaking, from history, the firewall used to sit between a trusted zone, the LAN side where you have your users, printers, IP cameras, and everything else, and an untrusted zone, which was the internet. And main scope was being to control traffic coming in from the untrusted zone. So traditionally speaking, you would allow all traffic to flow from the LAN side towards the internet, so from trusted to untrusted, and you would want to control only who can come in your network in the trusted side from the internet from the untrusted side. But nowadays, because as we were speaking the other couple of days, more and more attacks are easily being launched from the inside of the network. So the attackers have so many tools to control the host on the inside of the network. So you're going to be able to launch more and more controls from more and more attacks from the inside of the network. And as the network border becomes pretty much invisible, with a lot of people traveling and working remotely, or with a lot of BOAD happening, where a lot of people are bringing their own devices to work, and they have also their own devices which are going to be accessing the network remotely via whatever they're traveling to, or via from their home location, let's say. So the network edge becomes less and less touchable. It's pretty much everywhere. So with the range of attacks which are being launched from the inside, and with the fact that the network became borderless a long time ago, then having that in mind, it means that there's no more trusted zone. We have to control traffic flowing all ways. So both from the LAN side to the internet, and of course both from the internet to the LAN side. Now let's speak about what a firewall does exactly. Firewall design overview. So firewall is going to define traffic policies between its security zones, which a security zone is a vague concept, which is going to be something which you define in general. We're going to speak in a couple of ways as we go into more details of the firewall. But for example, on the ASA firewall, the security zones from the ASA firewall's point of view are going to be the security levels. While from the iOS zone-based firewall point of view, you have to actually define your own security zones. There are no security zones built in from the transit point of view. Of course, neither on the firewall we have security levels defined. We're going to see in a couple, but on the SA firewall, as soon as you define security levels, then by default those will behave like the security zones from the firewall point of view. While on the iOS zone-based policy firewall, you're going to define security names or zone, and those are going to be security zones by names, not by security levels, and those will be your security zones. Now, common, let's say, zone definitions is going to be inside, where is going to be your most trusted network, the LAN side, the outside, the least trusted network, the internet, and DMZ, which is somewhere in between, where you usually keep your publicly available servers or services. So speaking about from the previous slide, where for example in regular firewalls, from historical speaking, you would allow all traffic from the LAN side, from the inside zone to the outside zone. So that's why you have trusted to untrusted allowed by default, and then untrusted to trusted disallowed by default. Then the DMZ is kind of in between, because in the DMZ zone you would put your publicly available services, which have to be accessible by both the users and the internet. And maybe also from the DMZ zone you may need to access some resources from the inside zone, from the LAN side. So that's why it's kind of like in between. It's not a trusted, it's not an untrusted, because it has to speak with both worlds. It's also gonna be accessible by both the inside, the trusted side, and also by the outside, the untrusted side. So in general, we have either two zone firewall design with inside and outside, where, as we were saying, nowadays you have to control traffic both ways, but in the old ways, in out was allowed by default, out in drop by default, and that was good enough. Likewise, we have a three firewall design zone. We have inside, DMZ, and outside, and you can control which traffic is going to flow where exactly. Of course, you can define as many DMZ zones as you want. So you're gonna do a logical grouping of the DMZ zones. You can define multiple DMZ zones based in general on the role of the servers you have in the DMZ zone. So you may create two DMZ zones. One is going to be, for example, for your web servers, and one for your FTP servers. Or it's going to be one for your web and FTP servers, and the other DMZ zones for your VPN gateways, for example. And of course, you can give different names in there. These are just generic terms and names. It doesn't mean you have to use those exact names as you build your network. So you can name the inside as trusted, the outside as untrusted, and DMZ you can call it like VPN or like web servers or whatever. These are just generic terms for the sake of the example. Now, from the firewall evolution point of view, so let's see what were the first versions of the firewall and how this evolved, and we're going to speak about each of those in detail. So first we had what is called packet filters, which are stateless in nature. We're going to speak in a couple about what that means. And those are going to be the regular access lists. So if you know what access lists do, you have your answers on why those are stateless in nature, are going to be stateless firewalls or stateless or just packet filters, because of the nature of the access lists. After the packet filters, they came up with the application level gateways, or ALG, which those are known as proxies, or most commonly known the web proxy servers, which we have spoken about previously a bit as well. Then they finally came in with what is called the stateful packet filters, or known as the firewalls nowadays, because pretty much all firewalls nowadays are going to be stateful packet filters. And those are going to combine ACLs, so the packet filters, with the application level gateways, do the inspection of traffic in a stateful manner, and also are going to have added features. And finally, we have the next generation firewalls, which is mostly just a marketing term, because pretty much the next generation firewall, what it does, it's like a stateful packet filter. It's going to do stateful firewalling, but it's going to also provide additional security functionalities to address nowadays security requirements. We're going to speak in a couple about what those are. but most of those features were available to begin with even in stateful firewalls. It's just the way we do those inspections nowadays which for real makes them like a next generation firewall, because it's going to address next generation security requirements, to call it simple.